Yeah? Were you guys here last time I was here?
Yes.
You were? Do you remember any of the experiments we did?
We did that thing with the dragon.
The thing with yeah, I had a dragon with me, that's right. Most important question. Anyone remember my name? No. Well, my name is Laboratory Lauren, and I'm from Mad Science. So yeah, last time I was here, we did up, up, and away. We had a dragon breathing smoke, and we had things flying, and we had a hot air balloon going up to the ceiling. Today is a little different. Today I have something called spin, pop, boom. So we're gonna do some spinning experiments, some popping experiments, some booming experiments, some fun experiments, hopefully all fun experiments, and we're gonna have some fun. Mad scientists. Any of you guys ever leave cups around the house that are half full of water? Anyone ever done that? Yeah? You do it? I do it a lot. And I was getting ready, and I kind of started drinking from my cup, and then I set it down, and I lost it. So then I had to find another cup, and I filled it with water, and I was drinking, and then I set that one down. Do you guys ever end up with just a million cups lying around? It's a problem. But I think I'm going to clean up a little bit. Do you guys mind if I just clean up right now? Is that fine? All right. Who wants to help me first? Who wants to be a first volunteer? Is that you? Come on up. You're going to help me clean up because I don't like cleaning up. So I'm going to let you clean up for me. Can you take this cup of water and pour about half of it into this cup? Ready? Hold on. We're going to do it right over here so everyone can see. Just pour the water in. Pour it in. Pour it in. Wait a minute. I wanted water, not juice. My friend, you can take a seat. How? Hold on. That was clear water. How do we turn water into juice? How do we normally make juice? We take either like grapes and smush them. We take Kool-Aid powder. We add it to a cup. You don't normally mix two clear things and get juice, do you? No. I don't want juice. What I really wanted was water. I don't like grape juice. Okay, let's do it again. So now, you want to do it? Come on up. So when we poured the clear into the clear, we got juice. So I need a hypothesis of what's going to happen this time. What's your guess? What's going to happen?
It's going to turn into orange.
It's going to turn into orange juice? Mm-hmm. Okay, really good guess. What do you think?
Turn back to water.
Turn back to water? Ooh. That's crazy. Let's try. Whoa. Whoa. Okay, let's get all that little extras out of there. Guys, we had water, then we had juice, and now we have water again. Did you guys think that was really water? No. Good thinking. So let's use our brains and figure out what it was, because it definitely wasn't water. Glue? Yeah. When you take glue and pour it into other glue, does it turn pink? Have you ever seen that? Because that would be the coolest glue I have ever seen. What about, so it was a chemical, that is correct. What about something we use in soap? Do you guys think it could be soap? Yes. Does soap usually turn things pink? No, soap usually, if you had like pink paint on you, it would make you clean. So let's do this experiment again, and I'm going to show you guys how I set it up, because I did a few things before you got here. None of those was actually water. I think we all figured that out by now. In this cup, I started with water, but then I added a special chemical called phenolphthalein, which is a great science word. So it is also clear. But I'm going to add a little more just for fun. So this clear liquid into that clear liquid turns a little bit like milky white for a minute. And then when we swirl it, it goes back to clear. So this is what I told you was that first cup of water. And it was water with phenolphthalein, which is something called an indicator. So indicators can tell us if something is an acid or if it's a base. Do you guys know what an acid is? No. An acid is something really sour. So like lemon juice, vinegar, things like that, that when you eat them, or no, they're not all foods, you go, because they're really sour. Like if you guys had those warhead candies that make your whole mouth hurt, ugh, I don't like them. Really, really sour. So when this stuff is in the presence of things that are sour, it stays clear. But the opposite of an acid, do you guys know? What is it?
Base.
A base. What's a base? Do you know?
Like something that's solid.
It could be solid. In this case, it is. Yeah. What else?
Why?
Why? So you're thinking like the base of a pyramid or something. That is a different word with the same exact spelling. So you're very right. A base is the opposite of an acid. So they're usually really bitter, and a lot of our household chemicals are bases. Things like the cleaners we use under the sink that we obviously are not messing with. Things like what the ingredients with soap. So one of those ingredients is called sodium hydroxide. And you guys will notice a lot of my chemicals have Mr. Ick on them. Have you guys ever seen that symbol before? Do you know what it means?
Gross.
Gross? Correct. What else does it mean? It means that it is not something that we want to be eating. So if you ever see a cleaning supplies or anything like that your grown-ups might have at your house, that means not something that you want to eat. Things that we would want to keep away from our little friends like this one over here. Because you guys can know not to put things in your mouth, but sometimes our baby friends don't always know. So water is okay to go in mouths, that's fine. But any chemicals where you see Mr. Ick means they are not to be messed with. So I'm going to do this experiment again, but I'm going to show you what I did ahead of time. So in my first cup, I put a couple crystals of sodium hydroxide. That was a lot. We'll go with it. Get rid of one or two, because otherwise this experiment will never end. There we go. A few. All right. To that, I added a little bit of good old-fashioned water. Real water, not fake water, not chemicals, just good old water from the sink. And I gave it a swirl until it dissolved. So we can see those crystals are in there. They won't be in there for long. Swirl, swirl, swirl. So this was cup number 2 of water, but it's not water, right? It's water that is also a base. Cup number 3 was never water at all. It was vinegar. Do you guys know what vinegar is used for? It's definitely used for slime. Are you making slime with vinegar? I've never made slime with vinegar. That might be some cool slime. A lot of people use it to do like volcano experiments where you add baking soda and vinegar. It's also used for cooking. I mean, cooking is important. Yeah, make pickles, delicious. Cleaning supplies, yep, it's really good to like when you're trying to clean those kitchen counters that have food stains. Vinegar water works really well. So now we're back right where we started, right? We have what looks like 3 cups of water, but none of them are just water. This one, no. This one is water plus phenolphthalein, which was that indicator. This one is full of that sodium hydroxide. This one is a base. And this one is full of our vinegar, which is an acid. So when we took our first cup and poured it in, instant pink. The more we pour in, it gets almost like red. It's almost cranberry juice. And then what's cool, I'm going to add a little bit more vinegar so we can make sure we can really see it happening. Oh, I'm spilling all over, that seems right. So when we pour this one in, what I told you was juice was really phenolphthalein. And when you pour in just a little, it almost just disappears. The more we pour in, eventually we might get to the point where there's so much of the sodium hydroxide in there that it turns pink again. Depends how much vinegar I added. But we can pour that whole cup of juice in there and it's gone. So that's like a good sciencey magic trick. If we add those extra couple pieces, we can see if we can get it to turn pink again. Maybe not. There was a lot of vinegar in there. A little bit pink at the bottom as it's dissolving. So you see it? Do you see as it dissolves? Those areas right around the crystals are really, really strong with that base. But as they dissolve and as they mix in, you'll see in a few minutes, they're going to be totally gone. So good little magic trick to start. But I don't want to do magic. I want to do science. I want to see how smart you guys are. So if I took, I need another cup. It's not full of vinegar water. Where'd my cups go? There we go. If I take a cup full of water and did something crazy like flip it upside down, what would happen to it? Obviously, correct? So I'm not going to do it, but we know if I would take this cup and put it upside down, I would either be covered in water, it would be a whole mess, right? I think I have a way that I can do it without getting wet though. Let's hypothesize, let's take some guesses. How can we do it? Help me think of some ways to turn a cup of water upside down without making a mess. Yeah? Putting a bucket under it? Sure, so turning it right onto the bucket. So of course, right? I could turn the cup upside down like that. But now it's not a cup of water, right? Now it's a cup and some water. So I need other ideas. Freeze it? Okay. Did you bring your pocket-sized freezer with you?
I sure did.
Great, bring it up. Let's do it. Let's freeze it. I love it. I do have some ice with me for another experiment, but I don't think we all want to sit here and wait for this cup of water to freeze just so I can turn it upside down, right? You guys don't want to like sit here for an hour? No, not cool. Other ideas? Yeah?
Put another cup inside of it.
Put another cup inside. Okay, let me grab another matching cup. I like it. I like it.
Good idea.
All right, so what are you telling me to do? Like this?
Yeah.
I think it's gonna make a mess. You wanna do it?
No.
Hold on. Hold on, let's get a bucket. Let's get a bucket, I think this might make a mess. Ideas I've never tried. I brought a bucket just in case. All right, so you are telling me that I should take, this one's the cup of water, put this one inside it, and now I can turn it upside down?
I think so.
You think so?
No, you have to, I think you have to
Push it down? Like this?
Oh, no, that's not the one.
Uh-oh, that didn't work. Okay, more ideas. Let's go, yeah.
You put the cup under the cup and then you put the cup under it.
Come show me. There's still water in here. But then I have another cup of water, but I don't have an upside down cup of water. All I want is one upside down cup of water. We need to keep thinking. We need to keep thinking. You have an idea? You can tell me.
Maybe a lid?
A lid. Did you bring one?
Maybe your hand. Yeah.
Maybe my hand? Nope. Worth a try. If I had bigger hands, that might work. All right, we need more water though.
You have something flat.
Something flat. Interesting that you say that. I do have something flat. I have this big wooden thing. You guys think that'll do it?
That might make a big mess.
Yeah, like that.
And then flip it real fast? Let's see.
Really tight.
It's just water. If it gets on the carpet, no one will know, right?
Right. It might clean it.
That did work.
You can't lift it up,
Uh-oh.
because if you lift it up,
We'll be in trouble.
we'll be in trouble.
So let's try a different way. Still using this big wooden thing though. But I'm gonna dry it off because I just got water all over it. All right, we are gonna use this thing indeed. So this thing has some strings on it. And I'm gonna put the water right in the middle, just to prove that there is still water in here. I don't want you to think I dumped it out, but I'm gonna put it right in the middle. Move the bucket for safety.
This is cool.
All right. So if I swing it, we've got water on there. Think I can go all the way upside down?
Yeah.
Yeah? You trust me. Do you trust me? You look like you're ready to get a shower. It's just water. Ready? Whoa. All right. Is there still water in there? We're going to do this again. Don't worry. There's still water in there? All right. So when that cup is on the platform and I swing it around and around and around, is that water falling out when it gets to the top? What if I were to swing it slowly? Then would it fall out?
Yeah.
All right, let's stop it. Stopping, it's the hard part. So that water, just to prove that there's no glue on the cup, there's nothing in the cup, we know it's not a trick cup because we've already spilled it and made a mess. Mad scientists, we need to figure out how this works, and then you guys are going to try it.
Oh, wait.
Don't worry.
You're gonna try.
I'll let you try it with something that's not water. How's that? So when I swing it, right now when I'm just standing here holding it, gravity is pulling the water what direction?
Down.
Down. Gravity is pulling down. When we get all the way to the top of the swing, what way is gravity pulling it? Still down, right? That means there has to be another force in play. And that force is called centrifugal force. So when I swing it, you'll notice, if I would just set it down, it's ropes, right? They get all loose and wiggly. But when I swing the platform, they stay tight. Some force is pulling that platform away from the center, which in this case is my hand. So when we put that water on, you gotta swing fast enough to keep it tight, to keep that centrifugal force pulling on that water.
If you do slow,
If I do slow, it will not make it. I'll let you try that one, because I don't need a shower. I already took a shower this morning.
I don't need one.
Who wants to try? We're gonna try with an empty cup first. All right. All right, here. We will try. I brought with me a cup of Mad Science slime. We're gonna do it the first time that you guys try it with the lid on for safety. You're trying it first?
Yeah.
All right.
I'm gonna try with that, but no way with the.
Let's see how you guys do. It does take practice. The easy part is swinging it. The hard part, stopping it. So my friend, turn around so everyone can see you. Take this thing. Nicole, hold your arm out so you don't whack yourself in the legs with it. Start, just give it a swing. Side to side. Whoa! Okay, now stop it. Oh. You okay, my friend? All right.
She said, stop
That's why
it.
we said stop it gently. Are you okay? And would you like to try again?
With water.
You're trying with water? You would have gotten a shower if you did that with water. All right, can I show you how to stop it?
Yeah.
All right, ready? So we're gonna get it swinging. And you can swing either direction in front of you. You wanna take your arm and kind of step with it. So don't stop it when it's at the top, stop it when it's at the bottom. Try it again. Try again with the slime cup first. If we get a shower, it's just water. I'm moving out of the way. All right, big swing. All right, and now stop it at the bottom. It's okay, it takes practice. The stopping part is hard. Let's give her a chance to try. All right, we're gonna try with the slime. So first, before I even put the slime on there, just give it a good swing. Side to side, good. Do you wanna go all the way around before I put the slime on? Do you wanna do all the way around? Good. And now stop it at the bottom. Whoa. I have a feeling we may all get showers. All right, you ready? I'm moving out of the way for safety. Try and stop it at the bottom, not the top. Oh, you gotta swing faster than that. Try again. We have time to practice. Faster, faster. Swing. And stop. Woo. That went flying, but it didn't hit you in the head, so that's a good thing. All right. Do you guys want to keep trying until you get it?
No.
No? Okay, that's fine. We are gonna try it. I'm gonna do it with the slime with no lid, just for a little fun. I might get it in my hair. Slime in my hair is a good thing. A little snack. So our slime is gonna stay in that cup just like our water does. Just to prove that I can. You know, gotta show off a little. Buddy, did you wanna try it again? You wanna try it with water? Okay.
Yeah, I have a feeling no one's gonna get a shower.
I mean, worst comes to worst, it's just water and water dries. We're gonna do it with just a little bit of water. All right, is that enough water to prove that there's still water in there?
Yeah.
Is that too much?
It's fine.
All right, remember, your goal. Start by swinging it, go up and over, and then slowly stop at the bottom. I fully believe that you will get up and over. It's the stopping that's real tricky. Go. Wow. Take a bow. That was amazing. All right, maybe the water's easier than the slime. I mean, that was amazing. I'm impressed. That was some skill. All right, let's find a practical, real world version of this. Do you guys do your own laundry? Sometimes. So when you do your laundry, I love hearing that, you put in the soap, you wash the clothes, and then you put it in the dryer, right? When you dry, sometimes people use those dryer sheets. I don't like those dryer sheets because they're not very good for the environment. So have you guys ever seen one of these? A Downy ball?
Yeah.
Do you guys have one of these?
No.
What this is a little ball with a lid that pops in and out. Come on in, guys. This works the exact same way as our spinning platform. So when I had my spinning platform, what was the name of that force that pulled outwards on the water to stop it from flying away? Starts with a C. Do you guys know? Centrifugal force. Also some centripetal acceleration, but we don't need to get into that. So our water is pulled to the outside. We can do the same thing with our Downy ball. So this thing has this little lid in here that pops in. You put this in the wash, but you don't want it to come out until a certain time when you're washing. The soap comes out, your clothes get all clean, your clothes are getting rinsed, and that's when we want to add our fabric softener. In this case, our fabric softener is represented by water. Thank you, exactly, by water. So, because we're on the theme of laundry, the lid is on. That water cannot come out. But we're going to represent the spin cycle of our washing machine. If we spin it fast enough. Did you guys hear that pop? Did you guys get a spray? It's just water. We love making messes here. That is exactly how this works. So next time you're doing laundry, remember that there's science all around you. Do you guys want to try that last experiment since you just came in? Do you want to try spinning water up over your head? You're good? You're good? Okay. We had a successful volunteer over here, but let's move on to our next one. Now, I know some of you guys were here last time I was here, and I brought back one of my very favorite experiments because it's just so much fun. It's the one that lights on fire. It's called the flaming didgeridoo. Do you guys know what a real didgeridoo is? No. It is a wooden tube instrument that the Aboriginal people of Australia use. So Mad Science is worldwide. We borrowed this experiment from Mad Science of Australia. Now this is not a real didgeridoo. This is a plastic tube. But the real didgeridoos are made of wood, and if we tried to light them on fire, they would burn. To play a didgeridoo, you kind of blow across it and make like these weird throat vibrations that make a very cool noise. I have tried, I cannot do it. And that would not be fun for you guys to watch, to see me just blowing into a tube, because that's not fun. But we can use science to do this. So today's show is a lot about energy. So we are going to add a chemical and do an energy transformation in front of your very eyes. Does one of you guys want to help me out with this one? It's okay, you don't have to. These guys can do it. I promise, this one's gonna be worth it. Come on up, bud. All right, here is what I am gonna do. I need to find my ethanol. Our ethanol, again, has Mr. Yuck on it, which means it is not something we are going to drink. But I'm gonna add a squirt of liquid ethanol. Ethanol is an alcohol. It's actually very similar to gasoline. Obviously, we're not drinking it, but we do know that it is very flammable. You, my friend, need to turn this liquid ethanol into gas. Take that, put one hand on top, on the paper towel, and shake the tube into a big circle. Face the front. Big circle like this. Mix it up, mix it up. Turn all that ethanol from a liquid to a gas. It is a very volatile chemical, which means it is very easy to go from a liquid to a gas. Do you still hear liquid sloshing around in there? No? All right, then I think we're good. Ready? Is there liquid still in there? I'm gonna pour it out. Get rid of all that liquid. There's a little in there. Get a little more. Go ahead and take a seat, my friend. You did a very good job. I think I just poured a lot in. We have all of that gas, that ethanol gas, and I want it out of there, and the best way to get it out of there is with fire. I'm gonna do this once, then we'll talk through how it works. So, kicking buckets. I really am making a mess today. That's just fun. Oh, I need a left glove. I forgot which hand I was using. All right, so we are going to dump out all of our liquid, get it all out of there. Ready? We have all of that gas, all of that ethanol gas is in there. Let's light it on fire. That sounded cool. That is what a didgeridoo sounds like. Not quite that fast. How did that happen? Let's talk it through. What did you guys see? What did you see?
Fire.
You saw fire. Were you able to notice where the fire traveled? What did you see? To the end and then almost like kind of bounced back up, right? What did you see?
You put liquid in there and then you had to shake it up and then turn it to gas.
Yep.
And then like it went up and then went down and then went back up.
Yeah, so the fire almost looked like it was bouncing, right? So we're gonna leave this one because if I let enough oxygen back in here, we may be able to do it again at the end. We'll see. Gotta get some of that ethanol out of there. Should we do it again with the big one?
Yes.
Of course we should. Who wants to shake this one up? You're shaking it? Come on up. All right. Ethanol. Going in. Oops. All right. Paper towel. Over the end. One hand on that, one hand on it. Give it some good shakes. Shake it up, shake it down. Flip it back this way. Let's get it all in there. There you go. Really take that volatile ethanol and turn it from a liquid into a gas, because the liquid ethanol is not what burns. It is the gas. So we have a phase change. Do you guys know what it's called when we go from a liquid to a solid? What's it called? So, not a liquid to a solid, that's crazy. A liquid to a solid is freezing. What about a liquid to a gas? All right, that is good, my friend, thank you. A liquid to a gas is called evaporation. So when there's a puddle outside after it rains and you see that puddle and then you come back later the next day and that puddle's not there, it is because it evaporated. Yes?
I learned about it.
You learned a lot about that, about phase changes? It's awesome. We take our ice, so if I grabbed an ice cube and held it in my hand, we would go solid to a liquid. If we then let that water boil, it would turn into steam, it would evaporate. But let's burn this one. You ready? Pour out all that extra liquid. Now this one is a different shape and size. So let's see if it burns a little different. Now that you know what to expect, try and keep an eye on that flame. Are we ready? 1, 2, 3. Kind of fun, right? You can see it go all the way down. This one's a little longer, so it goes a little more slowly. Did you hear a difference? What was the difference? You heard it.
It wasn't as loud and you actually heard it traveling down.
Wasn't as loud, and it was a little bit of like a lower pitch because this is a bigger tube, so there's more resonance. So these tubes, when that energy was converted, we burned that ethanol and it burned so quickly that it made the tube vibrate. So if we take our didgeridoo and just, there's a difference even when we just do that, right? Now let's see, if we can let these air out enough, I may be able to do this experiment one more time at the very end if you guys remind me. But let's see what else we have. You guys just did a rainbow craft, I saw. Let's do a rainbow experiment. So I'm going to come behind the table for this one, and I'm going to talk through it because this one takes a little bit of time. Get some of my extras out of here. All right, I have what I call the rainbow maker. So the parts of the rainbow maker are this very, very large Erlenmeyer flask. There's about a ½ inch of water in the bottom of this, and what we are going to do is let that water boil. I'm going to turn on a hot plate. And it's going to start getting warm. It's going to do that while I set up. We need heat and we need cold. Cold in the form of ice cubes. So this is just an ice bath. Very cold. So we now have very hot, or we will have very hot at some point, and we have very cold over here. We are going to go from hot to cold. in order to see our water and make it a true rainbow experiment. I'm gonna dry off my hands, I'm making messes everywhere. All right, we are gonna add some food coloring to our water. In each of these 3 flasks, it is just good old water, real water, not the fake water from before. I'm gonna add some blue to this guy. Oh, it's starting to get bubbly. Some blue, some red to our middle one. I mean, this time when we add red to red, we get red to clear, we get red. That makes sense. Before, when we added clear to red, or clear to clear and got red, that was weird. And yellow. 1, 2, 3, 4. Okay. 3 flasks. Let's give them a swirl. Come on, red. There we go. All right. So what are these 3 colors that we have here? They are the 3 what kinds of colors? Do you guys know your art skills? These are the 3 primary colors. What do we know about primary colors? What can you guys tell me about primary colors? Yeah, you look like you're about to raise your hand. What are you going to say? We got time while this water's boiling. What do we do with those 3 primary colors? If these were the 3 primary colors of paint, what would you do if I said I wanted more than just 3 colors? What if we mixed them? We can make all of the colors of the rainbow, right? So let's talk it through. We have yellow that we could mix with red. What would we get? Orange. If you know it, you gotta say it. No one's too old for this. What about if we mixed red with blue? What'd you say? You got it. What if we mixed blue with yellow? What would we get? Yeah, green. Good job. All right, I'm holding this other tube away so we don't melt it on the hot plate because this is very hot. Mad scientist, I'm just holding this cork on. Do you see that blue one starting to bubble? Now that blue one is not actually boiling. The water that's in here is boiling, and when that water boils, it makes the air inside expand. You notice this crazy set of tubing that I set up. The air in the big one is expanding. It is expanding, getting bigger, and forcing its way through the tubing into the blue one. That is then forcing the air from the blue one into the red one. What's happening after that? The red one is expanding, going into the yellow one. It all makes sense. So it looks like they are all boiling. They are not boiling, they are just bubbling. Our hot air that is expanding, I want to now make it shrink and see if we can't get a good reaction. So I'm going to keep holding this cork on, turn off my hot plate for safety, and really quickly cool this air. Now this experiment takes a minute to happen. Let's keep an eye on it. You ready? Keep an eye on those flasks. Let's see if we can't cool that air real quick. What's happening in the blue one? It's coming to the red one. What's happening to the red one? Red one's moving. Try and get it really cold. Keep going, keep going. Let's get them in the mix. There we go. Oh, yellow's starting. Let's get some color mixing. Hopefully we can get some red turning orange, some blue turning purple. Trying to cool different parts of the bottle. Keep it going. We can see it's flowing, it's flowing. Hopefully we can get it to go all the way. It looks like it's bubbling, but it's just pouring. The blue is really starting to turn purple. It's going, and that blue is actually draining into the big flask. Yellow is pretty much empty. I'm just gonna keep spinning this. Yep, I'm gonna spin this to hopefully get some more of that air cooled. Don't give up on me now. Keep going, keep going. That might be as far as we get. So mad scientists, we need to talk through what just happened. It's still going a little tiny bit. That blue looks like it's trying. It's trying. Come on, blue. Can we get more blue out? Maybe. That might be as far as we get. All right, mad scientists, I'm gonna leave this to cool. Once again, I need to dry my hands because I end up soaking wet every time, but not because I spilled water on myself this time, luckily. Let's talk through what happened. How did the water get across? Our air, when I heated up that giant beaker, giant flask, was very, very hot. That air all expanded. It then bubbled through. We saw blue bubble, then we saw red bubble, then we saw yellow bubble. They bubble, they bubble. They were not boiling, they were just getting little bubbles through them. Kind of like when you blow bubbles in your drinks, when your parents probably tell you not to, but through your straw you blow and you get bubbles in your milk and it looks really cool. As long as your parents say, okay, you can try it once or twice. Those bubbles were coming up because all of that hot air was coming out and expanding, and then it was coming out this guy, which was open. Now that one that was open, we had to let that air go somewhere, but then I real quickly took the big giant flask, plunged it into that very, very cold water. Do we know what temperature that water was? Anyone know what temperature ice freezes at? Do you know? You look like you know. 32 degrees, very good. 32 Fahrenheit or 0 Celsius if we're being scientists, but we can be scientists with both scales, that's fine. As that air contracted or got really, really small, it created something known as a vacuum, which means all of that air pressure was a low pressure and wanted to suck the other air in. So it started pulling air through the tubing. We noticed it started pulling from the blue, then it pulled from the red, and then it pulled from the yellow. We got all of the yellow into our red, making kind of an orangey color. At that same time, that red was flowing into the blue, making purple. Because we also got some yellow into the blue, we also kind of end up with like a blackish color, because that's what happens when you mix all of them. But that's what we call our rainbow maker, because we make most of the colors of the rainbow. We never really get green, because the yellow hits the red before the blue, but we see some of it. And then just to show you guys how much ended up in here by the end, so a lot of our bluish purple water ended up sitting in the big one. Let's move on. Ooh, I am covered in food coloring. That's fine. All right, I'm going to move the ice bath out of the way so that I don't spill it. Oof. Okay, we are going to move on to an experiment with a genie. Now, what do you guys know about genies? Yeah, what do you know? Where do they live? What do you know? Magic. They're magical, correct. Where do genies live? They live in a lamp, right? Right, like Aladdin, you rub the lamp, the genie comes out. Now we're gonna see if there's a genie living inside this lamp, which is actually a boiling flask, but it's kind of like a lamp. Do you guys think there's a genie in there? No? Okay, then we'll just skip the experiment. Just kidding. Let's see if we can make this one work. Hopefully there's a genie inside. Let's rub the lamp 3 times. 1, 2, 3. Pull the cork. Ready? See if a genie's coming out. Do you see him? No. He looks like he's coming out, but I don't see an actual genie. You see smoke coming out? Genie, are you there? Are you there? Now that was cool, but we need to figure out what it was. So I want to do this same experiment again without the magic lamp. So this also gets very toasty. So the sides of this beaker are very warm. It is an exothermic reaction, meaning it creates heat. Now I don't think there's an actual genie in there. Do you guys think there is? No, I don't think so. But let's do the experiment again so we can see him. I have another flask with me. This one is not wrapped to make it look like a magic lamp. But what we are going to do is we are going to take a paper towel, because I'm going to show you, just like I did with the juice experiment, I'm going to show you the setup that I did beforehand when nobody knew what I was doing. So we are going to take this paper towel and split it into its little layers so that it is really, really thin. Did you guys know that paper towels split in half like this? It's called 2-ply. It means they're the fancy paper towels. So we set that down. I'm going to add a little bit of this chemical, which is called manganese dioxide. It is a very dark pigmented chemical, and in this case, it is our catalyst. Now the word catalyst is going to come up again in our next two experiments, but I'm going to add some of that right into the middle, right there. And then I twisted it up. Now last time I tied a string to it so that I could lower it in front of you guys without you seeing it. But this time I just have a little bottle, a little bundle, kind of looks like a ghost, of our manganese dioxide. I'm also going to add a little bit of hydrogen peroxide. So do you guys know what hydrogen peroxide is? Do you know where it's used? Have you ever gotten a cut or like scraped your knee and your parents pull out this like brown bottle, again, Mr. Ick, and pour it on your knee? What happens when they do? It kind of burns a little bit. And what else do you see? It helps you heal, yes. It bubbles. So hydrogen peroxide is made up of two elements. Water. Have you guys ever heard of H2O? That's a scientific term for water, but do you know what it means? Do you know what H is? Yes. Hydrogen. So H2 means there are two hydrogen atoms. O, do we know what O is? Oxygen. So water is H2, two hydrogens, one oxygen. It kind of looks like Mickey Mouse. That hydrogen has two little oxygen ears on it. Hydrogen peroxide is H2O2. So what does that mean? It still has H2, two hydrogens, but what does it have more of? Oxygen, double the amount of oxygen. So hydrogen peroxide is like super oxygen-filled water. When you pour it on your cut, it is that oxygen bubbling with the blood that's on your knee that helps clean and heal your cut. Those bubbles are little bubbles of oxygen being released, but we can do that bigger. So let's add a little bit of hydrogen peroxide. That should be enough. And our manganese dioxide is our catalyst. This is what's going to make our reaction happen quicker, because you cannot see it, but that hydrogen peroxide is actually reacting right now. It is bubbling and releasing oxygen. That's why if you find an old bottle of hydrogen peroxide on your shelf and poured it on a cut, it will not do much. It might not do anything, because it might have turned back into water and oxygen. So expiration dates. This one's good until 2026. Once you open it though, it's slowly degrading. This is the same chemical, this is just a much stronger version. This is about 12%, this one is 3%. This one is actually what people use to bleach their hair. So this is what makes hair dye work. You guys want to see it again?
Yes.
Catalyst in our little bundle. That little bundle is just to keep it safe so that I don't have to touch it. And then we're going to drop it in. Ready? See if it'll work. And there's our genie coming out. Bubble, bubble, bubble. It's kind of fun. Still no real genie though. Hello, genie? Can you grant my wishes? No? No? No genie. All this smoke is fun, but we need to come up with a way to capture the smoke. How do we capture air bubbles? What's a good way to capture air? Ideas. Ideas. Idea. You look like you have an idea. How can we capture a little amount of air? Or in a cup? Okay, okay. So you are correct. This cup is full of air. If I pour it out, you don't really see it. But I mean, there's air. We know we're breathing air. So correct. And we already know my hand doesn't make a good seal with the cup. We learned that earlier when I poured water all over the floor. Mad scientists, this would be one way to capture some air or some gases. I bet that you guys have all experimented with captured air in the past and didn't even know it. How many of you have ever taken a shower? I hope the answer is all of you. If not, it would get real stinky in here. Mad scientists, when you put that shampoo in your hair and rub, 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 what happens? What do you get? Bubbles. And what are bubbles? Bubbles are full of air. They are little round films of bubble filled with some sort of gas. So we're going to try and do that same experiment again, but capture all of that air that's released. Think we can do it? Let's do it. All right, this one could get messy. Move some things out of my way. All right, I have with me this flask on a garbage bag, which will hopefully be enough to contain it. You never know. And we are going to do this 2 different ways. All right, into my flask, I'm going to add some of our hydrogen peroxide. About that much. I timed that out perfectly. All right, in order to make our bubbles, what did we need? Soap. We are making a bubble bath. Give it a good squirt. Now this is a boiling flask, but it is also very good for mixing chemicals because you can swirl. So now what do we have? We have hydrogen peroxide with bubbles in it. Is it reacting right now? Technically, yes, but we can't see it. Question, yeah? You don't have a question? Okay. We need to add a few more things to make this really go. First one is a little bit of food coloring because that's just fun. Do you guys have favorite colors? I have red, yellow, and blue. What do you got?
Red.
Red? What else? Blue? What else? Blue? Okay, so red and blue it is. Let's do a little stripe of blue and a little bit of red. Hopefully without getting food coloring on my hands this time, but hey, that's the woes of being a scientist. A little bit of red on this side. All right, we are going to add our catalyst. So what did our catalyst do last time? It made the reaction happen faster. I told you that reaction is currently happening right now, but not very quickly. There we go, too many little tubes up here. This chemical is called potassium iodide. It is a salt, kind of similar to the salt that you eat, but instead of sodium, it is potassium, and instead of chloride, it is iodine. Mad scientists, when I add this in, something is going to happen. I don't know what. Should we do it? Yeah. Ready? It's going to start bubbling. It's going to bubble. See if we can get it to grow. It's growing. It's growing. What is coming out? What is happening in this tube? It is what we like to call elephant toothpaste. So the red and blue that you guys chose happened to work out very nicely. Do you also see all of this steam coming off? All of these bubbles are full of what gas was released by the hydrogen peroxide? Do you remember what it was? I'll give you a hint. It's what we breathe in. Oxygen. Air, yes. So our air that we breathe is a mixture of nitrogen, oxygen, carbon dioxide, a couple other things. This is full of oxygen. We were able to capture all those bubbles. Yes?
I was talking this morning. I didn't know we were going to do this.
You didn't even know? But have you seen the elephant toothpaste experiment before? Maybe on a famous YouTuber? Yeah, my friend Mark Rober does it. Really, really big, right? Now, I didn't think it would be cool to bring like a big giant bathtub with me and fill it. I thought that might make a little bit of mess and we might hit the ceiling. So we did it a little bit smaller. But I'm also going to do it one other way that is a little bit different. But it's a way that with grown-up permission, you guys can do it at home. So this one stayed nicely contained in the bag. We are going to move this one out of the way. All right, off the tray. Love it when my messes stay contained. That doesn't always happen. All right, we're gonna do it one more time. Another garbage bag, because we never know. Never know where this might go. All right, and we are gonna use the lower grade of hydrogen peroxide. Oh, that bag's not open. There we go. Come on, bag. Thank you. All right, I have with me another boiling flask right in the middle of our tray we are going to add some of that other hydrogen peroxide. This one is the 3%. And this one gives a little bit of a different reaction, but still very cool. What is the next chemical that I added? Who remembers? Who remembers? What was it?
Food coloring?
Before, well, I did add food coloring. Before that, I added our bubble catcher. A little bit of dish soap. Close that up. Give it a swirl. All right, what color should I make this one? You just walked in. What's your favorite color, my friend? Yeah, do you have a favorite color? Green? All right. I don't have green food coloring, but I do have the primary colors. What do I need to add to make green? Yeah? Blue and yellow. So let's add a few drops of blue and a few drops of yellow. This time I'm going to swirl it around, so we're going to get more of an even color instead of the stripes. We're not going for the aqua fresh, we're going for the peppermint this time. All right, in another cup, I have a very simple chemical that we sometimes use. How many of you guys like bread? What makes bread rise? Do you know? Yeast. Yeast makes bread rise. So we are going to add some yeast. Going to add some water and try and get our yeast to wake up. Now this is instant yeast, which means those yeast are sleeping but ready to go. I'm going to give those a swirl. I'm going to pour them in here so I can give them a better swirl because that was not enough of a container to swirl. Come on, yeast, wake up. There's a big clump in there. There we go. It's just yeast, so it is safe to do with my finger. Kind of gross though, kind of clumpy. All right, now that I am all goopy, get that all in there. We are going to give those yeast a minute to wake up. So before, our potassium iodide was our catalyst. This time our catalyst is our yeast, which is what's going to make our chemical reaction bubble. Hydrogen peroxide, H2O2. Hydrogen, we got to get rid of that extra oxygen. This is what's going to do it. You guys ready? Yeah. All right. Let's see if this one can stay contained too. If not, I'm cleaning up a big mess. Let's go. Bubble, bubble, bubble. Go, go, go. Really is kind of pepperminty. So this one bubbles, doesn't go as high, still just as fun. With parent permission, this is one that you guys could try at home. Mad scientists, thanks for inviting me today. We do have a few minutes if anyone else that got here late wants to try spinning the platform. If not, you guys are free to move on or ask me any science questions that you have. If you guys have questions about any of the stuff we did, we do birthday parties, we do school shows, we do all sorts of things. So if you, any grown-ups, are interested in having Mad Science come to your school, house, library, village hall, anything, come find me after. But that's all I got for today, guys.